Hello, in this video lesson we're going to look at section 9.5 about symmetry. Symmetry is when a figure is able to map onto itself through rigid motions. Rigid motions are translations like reflections, rotations, translations. They are the different transformations that are considered isometries. So a figure has symmetry if you can use one of those rigid motions to map the figure back onto itself, meaning that you can turn the picture, slide it, flip it over, and end up with the exact same image you started with. There are two different types of symmetry that we're going to focus on. One is called line symmetry, and the other is point symmetry. Line symmetry is what most of you think of when you're asked if an object is symmetric. Line symmetry is where you can fold a picture in half so that the two halves line up exactly, or when you can draw a line through a figure so that each half is the exact reflected image of the other half. In the first set of questions, we're trying to determine whether each figure has line symmetry. If it does, draw all of the lines of symmetry and state how many there are. When you take a look at the first picture, which appears to be a parallelogram, this actually does not have line symmetry. Often students believe that it does. If you're not sure, take your piece of paper and fold it along where you believe there would be a line of symmetry, and then hold your paper up to the light. If the two halves of the image aren't perfectly on top of each other, then that picture does not have line symmetry. In question number 2, this figure does have line symmetry, although there's only one way to fold this pentagon so that the two halves would be the same, and that's this way. So we can say, yes, this figure does have line symmetry, and there's only one line of symmetry. In question number 3, the rectangle definitely has line symmetry. We could fold the rectangle in half this way, and the two halves would be the same. Or we could also fold the rectangle in half this way, and the two halves would be congruent. So the rectangle is, yes, two different lines of symmetry. Question number 4, this arrow has line symmetry. It only has one, and that's if we were to cut directly through the middle of the shape and the tip of the arrow, just like this. In number 5, we do not have line symmetry. There's no way to fold this picture so that the two halves are congruent. And in number 6, this sort of plus sign does have line symmetry. So we could cut the plus sign in half, top to bottom. We could cut it left to right. But we could also cut this figure diagonally, once going this way, and then again in the other direction, going this way. So this plus sign shape has 4 different lines of symmetry. When you flip your notes over to the back side, we're going to look at point or rotational symmetry. Rotational symmetry is when your object can be rotated or turned about a fixed point less than 360 degrees so that you end up with the exact same picture. So we're going to turn our figures less than a full turn, less than 360 degrees, and end up with the exact same image. When we talk about objects that have rotational symmetry, we're going to discuss the order and their magnitude. If an object has rotational symmetry, the order is the number of times that you can turn your figure to get the figure mapped back onto itself to get that exact same image. And the magnitude of symmetry is the number of degrees that you're turning that image each time you map it back onto itself. To find the magnitude, we're always going to take 360 degrees and divide it by the order. If you look at a very basic shape like a square has an order of 4. There are 4 different ways to turn the square and have the exact same image. Imagine the 4 vertices of the square. Each one of them essentially gets a turn to be at the top of this figure. So there are 4 different ways to turn the square that look exactly the same. Therefore, each time we rotate that square, we're rotating it 90 degrees to bring one of the new vertices back up to the top. So the order for a square is 4. Magnitude is 360 divided by 4, or 90 degrees. When we take a look at the examples, we're figuring out first if each figure has rotational symmetry, and then if it does, state both the order and the magnitude. When you look at question number 7, you can assume that this is a regular hexagon, and actually every single regular polygon has symmetry. For a regular polygon, the order is always going to be the number of sides. Just like the example with the square, if I took this hexagon and I turned it sort of like a Ferris wheel, each different side has a turn to be up at the top. So here the order is 6, same as the number of sides for any regular polygon. And then the magnitude is always 360 degrees divided by 6, divided by the order, or 60 degrees. That means for a regular hexagon, each time I rotate to have a different side on the top, I'm turning 60 degrees. In question number 8, this picture also has rotational symmetry. It has an order of 4. So again, being able to rotate this picture so that each of these triangles has a different turn up at the top. So here we have an order of 4, which means that our magnitude, always 360 divided by order, is 90 degrees. Question number 9. This polygon, this pentagon, is not regular. So unfortunately, this does not have rotational symmetry. We can't turn the object and end up with the exact same picture. Question number 10, we can assume is an equilateral triangle. Since that's a type of regular polygon, we know that it has rotational symmetry and that its order is the same as the number of sides. So an equilateral triangle has an order of 3. Magnitude is always 360 divided by order. So 360 divided by 3 makes the magnitude of our triangle 120 degrees. Number 11, this crescent moon shape does not have rotational symmetry. You cannot turn this shape and end up exactly where it is, less than 360 degrees. And question number 12, this sort of sun shape does have rotational symmetry. If we imagine each of these different pointy parts taking a turn up at the top, just like the Ferris wheel, this shape has an order of 8. So its magnitude, 360 divided by 8, is 45 degrees. Please make sure that you complete the 9-5 homework worksheet tonight. Have a wonderful day.